name is Caleb Padilla. This is Project1 ANSYS Fluent for EAS3101. Here we have our workbench open. We're going to go to Toolbox and scroll down to where we find Fluid Flow Fluent. We'll click and hold and drag that to the project schematic. Then we'll go ahead and click on Geometry. We will right click here on Geometry, click New Design Modeler Geometry. We'll go ahead and wait for this to load up. So we have this open now. We will click our XY plane and then click Z-axis, make it easier for us, have it face us. Also we will change the units to inches because the specs of the wind tunnel are in inches, not meters. Now we will start sketching, go to lines, and we will make horizontal lines, which will act as the length of all of our components of the wind tunnel. So we'll go to dimensions, hold and drag. We'll change this dimension to 15 inches, which is the length of the settling chamber. We'll go ahead and do the same thing and draw another line. Click line. And then we'll draw another line. And this will be the length of the contraction chamber. So go to dimensions. And then we'll change this to 24, the length of the contraction chamber. And we'll just keep doing this again for a test section. This line is for the test section. Drag out the dimension, and we'll change it to 12 inches, the length of the test section. And lastly, we're going to add one more line for diffuser. Drag that down, and the diffuser length is 42 inches. Okay, and now we're going to add vertical lines at each of the ends of the horizontal lines to act as the lengths of the components. So we're going to add them vertically at each point. This one here is the end of the test section, beginning of diffuser. This is the end of the diffuser. Now these aren't really that centered, so we'll go to constraints, and then we'll click on midpoint, click on the vertical line, and click on the point that we want to center it with, and then it'll clean it all up for us. And we'll do that for each of the lines, and as you can see, it is centering them. And from here, we can go to dimensions and change the vertical dimensions for the heights. So the first one would be the settling chamber, and the height of this one is 22 inches. Same here. The start of the contraction chamber, same as the settling chamber, 22 inches. Here is the test section, it's 12 inches. And here is the end of the test section, so also 12 inches, start of the diffuser. sorry, this is supposed to be 6. I was reading wrong. So height is 6 inches. Same here, the height is 6 inches. And this would be the end of the diffuser. We don't have that value given, but we're given the half diffuser angle of 3 degrees. So to find delta y, we take a tangent of 3 multiplied by the length, which is 42 inches. Multiply that by 2 and then add 6, and it'll give us 10.4 inches. And that will be the vertical length of the outlet. Here we'll draw more lines, and this will be connecting each point. It would be our wall of our wind tunnel. So we'll go ahead and make sure we're connecting at each point. Again here, the bottom side. And now we have our wall. So we can go ahead and delete all of our lines that we made for the specs, except for the inlet and the outlet, because it's part of the wind tunnel wall. So we'll go to modify and then trim and hover over each of the lines that we want to delete. So the horizontal lines we made, the vertical lines we made, except for the inlet and the outlet. Now we have our wall. So we'll click concept and surfaces from sketches. We will go up to this and press box select and extend it over the whole wind tunnel. That'll select the wind tunnel, and then we will go to base object supply and then generate. There we have the skin over wind tunnel. So now we are done with this portion, so we'll go back to the workbench. And here we're at our workbench, and I will open up our next portion, which is the mesh. So we will right click here on the mesh and click on edit, and then wait for it to open up. And here we are, we click the Z axis, make it face us. We'll click here on mesh. Now insert, and then we'll go to method. We'll click geometry, select the wind tunnel. Sorry, geometry. There you go. Now apply. From here, we will go back to mesh, change our element size to small value. And from here, we will generate. And we'll let this load. There we have it. There's our mesh. Now we'll click here on the edges, and then click here so we can name our edges as components. And this would be our inlet, so we'll name it our inlet. Press OK. And then we'll come out to the outside. This will be our outlet. Press OK. And then now we'll select all the other surrounding, as this will be the wall of our wind tunnel. So select all of it. Oh shoot. Select all the outside. And name this the wall. Click OK. Now we'll go back to the left. And our transition to Fluent was successful. So now we'll go back to the workbench. We're done with the mesh. And now we'll go move on to setup. We'll wait for this to load in. Now we get to this screen where we're going to select double precision, change the solver processes to 4, and then press start. And now we'll wait for this to load up. Now we have the Fluent open, so we'll come to the left side, click models, then viscous, as this is viscous flow. However, we're gonna double tap in the model. We're going to select K epsilon. We're gonna change the near wall treatment to enhanced wall treatment. We're gonna check the box of pressure gradient effects, and then click OK. These values are all good. Click OK. Let it load. So after that, we're gonna go into our boundary conditions. Open that up. Open up the inlet. And we're gonna edit our inlet velocity. So this here is gonna pop up, and we're gonna change our velocity magnitude. So we had to calculate the velocity of the inlet. We know that the area of the inlet times velocity of the inlet is equal to the area of the test section times velocity of the test section. We use the height for the area values, as the base of both would be the same. So our velocity inlet is equal to the height of the test section, which is 6 inches, times velocity of the test section, which is 4.6062 meters per second, divided by the height of the inlet, which is 22 inches, and that leaves us with 1.2562 meters per second. So we'll go ahead and enter that in here, 1.2562 meters per second. And then we'll click apply. Make sure that's applied. Okay, now we can close here. And then from here, we go down to reference values. And reference values, we make sure that we're computing from the inlet. And after we compute from inlet, we will scroll down, go to initialization, make sure we initialize. Initialization is done. Now we can go to run calculation. Just set for iterations. and calculate. My calculation is complete, so click OK. Now the calculations have been ran. We want to get the contours of the velocity, static pressure, total pressure, and dynamic pressure. So we'll go down to graphics. Sorry, open up graphics. Open up contours. We'll start with the velocity contour from the interior surface body, which will be the inside of the whole inside of this wind tunnel. Let's save and display. And so here's the contour of the velocity. Go in here, select pressure, then we'll get the static pressure contour. It's already selected, interior surface body, save and display. Come in here, just drop down, get the total pressure contour. And lastly, click this drop down to get the dynamic pressure contour. Save and display, and here's our dynamic pressure contour. Now we have all our contours. We can close this out. Let it close out. And then we can begin our process of exporting to Excel. So we'll come in here into results, come to create drop down, and then select line/rake. This new surface name will be centerline, as we are creating our own centerline. We'll change our type to a rake, select the number of points, and then our endpoints would be this. We're only changing the x value. This is obviously 0. X value would be the length of the whole wind tunnel. They asked for it in meters, so the length is 93 inches. Converting that to meters is 2.362 meters. And then we can create. Close out of this. Close out of this. And now to export, we'll click File, down to Export, down to Solution Data. We want it from the center line, and we want static pressure, dynamic pressure, total pressure, and velocity magnitude. We'll click right. Hold on. Sorry, we have to change the file type. ASC2, change delimiter to space. Now we can come down here to write. I think it's loading. There we go. File name, okay. Okay. And that concludes Project 1, ANSYS Fluent for EAS3101. Thank you.